Synthetic division, algebra 2, common core. So the video before this was long division. I just want to show you one slide from long division where we did divide, distribute, change, combine, and this was the process for long division. And the divisor was x minus 5, the dividend was this polynomial here, and the quotient we got was the 3x squared plus 2x minus 1. I want to show you the same exact problem of x minus 5 divided by that, or that polynomial divided by x minus 5. See, it's the same exact question. But I'm going to use something called synthetic division. And a couple of things about synthetic division. It is a lot quicker and a lot easier than long division. So why do we even bother to learn long division? Well, long division, you could divide really any polynomial by any polynomial. But synthetic division only works when the divisor is a binomial, and it has to be a degree 1. It has to be a linear, but see how this is x to the first. For long division, if we had something, just you don't need to write this down, just a little bit of scrap for something like, or let me actually use this question right here. So this original term here, 3x cubed minus 13x squared minus 11x plus 5. We can divide that by, of course, x minus 5 and get the quotient we got. But we could also divide it by 3x squared plus 2x minus 1. And work, instead of 2 terms at a time, we work in 3 terms at a time. And we would actually get x minus 5 as our quotient because together they multiply to that. So you can divide by a trinomial. Synthetic division, you can't do that. You can't divide by a trinomial with synthetic division. It's got to be a binomial like this. And so it has some restrictions. Really, synthetic division's main use is for testing roots, is what it's called. And what I want to show you is if I type this into my calculator, so let me get my calculator out here and I'll show you what I mean. And I also need to talk a little bit about the importance between a factor and a root. So this right here, this x minus 5 is called a factor. And by doing long division, we can divide by that factor. But if I were to say set that x minus 5 equal to 0, just get that error message gone, and solve for x, I would get x equals positive 5. This is no longer called a factor. It is called a solution, sometimes referred to as a zero, and what I call it often a root. And what I want to show you is, again, if I type this in, y equals, and we'll go 3x cubed minus 13x squared minus 11x plus 5. And let's take a look at the graph. What I want to show you is, and this is related to the next video called the remainder theorem, you'll hear me talk a lot about that, is that it's very significant, and I'm sure I mentioned this in class, that the remainder in this particular problem was 0. And what that really meant was that x minus 5 was a factor of this polynomial. So, and we see that we multiply these together, we would get that. That's what factors are. Just like regular division, if you divide something and the remainder is 0, that means that the divisor was a multiple of the dividend. Well, here with polynomials, if the remainder is 0, that means the divisor is a factor of the polynomial. And going even further than that, so x minus 5, we already know is a factor of this polynomial. And what we see when we set that equal to 0 and solve x equals 5, that's what we're seeing right here. That 5 is a root, an x-intercept of this graph. Let me add that to the list here. X-intercept. So the factors are what, the x-intercepts are what make up the factors, and the factors are what multiply to be the expression that you're working with here. And when you don't get a remainder of 0, well, then it's not a factor, it's not a root, it's not a solution, it's not an x-intercept, all that stuff. And that's really has to do with the remainder theorem that I'm going to talk more about in the next video. And we're going to use a lot of synthetic division in the next video and going forward to test things. So really what I want to show you is that I can do this division with synthetic division, but synthetic division requires these. It requires a solution, 0, or a root. we don't use factors when we do synthetic division. So if I want to do this with synthetic division, I have to turn the x minus 5 into an x equals 5. And it's very easy. Just set it equal to 0 and do what you have to do to solve for x. In this case, we had to add 5 to both sides, and that's why it's a positive 5 on the right. So that is the solution, or the root. And then we draw a interesting kind of bracket like this. And what we put up here, kind of leave like almost 2 rows. In the top row, almost like this upside down, we put the coefficients and the constants here. So I'm just going to put 3, negative 13, negative 11, and 5. So this is the setup for synthetic division. You don't have to have the x equals here. I'm just kind of showing you that that's where the 5 came from, is turning the divisor into a root. And we're testing it. We don't know that it's a root yet. I mean, we do, because we already did this question. We know the remainder is 0. But we want to keep going here. So we put the coefficients, and we saw that when we did the long division, we also need to check, make sure we don't have any missing exponents. We go 3, 2, exponent of 1, and then a constant. So everything's there. There's no gaps in the exponents, because if there are, we like to put a 0 in its place. And the same thing goes for synthetic division. So the way synthetic division works, you put the root out here in root form, not factor form, root form, and then you put the coefficients there. Bring the first number down to here. Multiply by the roots. So 3 times 5, and that goes here. You combine like terms in the columns, just like we did when we were working in here. And what do you notice? I have a negative 13 and a positive 15, and that gave me 2. Negative 13, positive 15, that gives me 2. Times the outside. It's always times the root on the outside. What comes out here? Times the outside. So 2 times 5 is 10. Negative 11 and 10 combined to be negative 1. Again, we'll see that we had a negative 11 and 10 here. So it really is kind of the same thing that's happening if you really get to know this process well. Times the outside is negative 5. They combine to be 0. What's left down here? Whatever the exponent was, the highest exponent of the dividend is 3. We go 1 less than that. So this would be 3x squared. And that makes sense if you think about it too, because we're dividing out an x from an x cubed term. You're going to be left with an x squared. And think about the long division. Our first term when we divided 3x cubed by x was 3x squared. So the first term is x squared, and then the next one is x to the first, and that leaves a constant. And then what's left over, the last number for synthetic division, that is the remainder. And again, we see it has a remainder of 0. So it's a very quick way to do division, of just writing these numbers, bringing them down. Basically, the variables kind of get in the way. And again, this would be great if we could always do this for division, but it only works if we're dividing by a binomial of degree 1. It would not work in this case down here, because there's just too much there. We can't do synthetic division with that. Synthetic division also gets a little tricky when there's a number in front of x, like if there's 2x minus 5. You can do it, but you can't really trust these numbers. But you can use it to find the remainder. If the question is just what's the remainder, or is it a root, that type of stuff, synthetic division is great. But if you really need to know the quotient, this piece, then it gets a little tricky when there's a number in front of x, and so it's not recommended. So you really do need to know both methods and know them well. So let me show you another example. Use synthetic division to find the remainder when this is divided by that. So first of all, for synthetic division, I got to turn this x plus 2 into a root, and that would be negative 2. Set up my little L bracket. Check my exponents. 4, 3, 2. I am missing a x to the first term. And so I'm going to kind of just make a note that that needs to be there, because that does need to be included here. So 2, 3, negative 1, 0, negative 2. 2, 3, it's a negative 1, 0, and the negative 2. Bring down the first number. You don't have to draw arrows, but you can if you'd like. Bring down the first number. Times the outside, negative 4. Combine these, negative 1. Times the outside, positive 2. Combine these, positive 1. Times the outside, negative 2. Combine these, negative 2. Times the outside is 4. Combine these, we get 2. The last number is the remainder. So we get a remainder of 2. And again, I'm going to go into it a lot more detail in the next video, but the fact that this is not a 0 means that this is not a factor of this. This is not a root on this graph. And that's really a lot of value there when we get into graph structure and things like that. So this next one, we'll save this one for class. You know, you'll see that some of these, sometimes I ask for you to divide by things, and then you'll see sometimes where it, you know, actually talks about, maybe not, I guess I was looking for something that had a x equals in it, but this is how we can do division, but we have to kind of realize that this is a special method that can only be used in certain scenarios, and, you know, it has its limits. If I wanted to write this quotient out here, since this is x to the 4th, it would be 2x to the 3rd minus x to the 2nd plus x to the 1st. I'm just not writing these ones, minus 2. And then we could say plus 2 over x plus 2. Remember, we always like to do remainder over divisor. But the fact that this is not a 0 means this is not a factor and this is not a root. And so you really need to understand the connection of factors and roots. And we're going to talk a lot more about that in the next couple of days. All right, guys. So that's it for synthetic division. See ya.